This is the Precision in Measurements video for chemistry. This video is designed to help you achieve 3 goals. The first is to be able to take a measurement in the laboratory to the appropriate number of significant figures. The second goal is to understand that significant figures include all of our known digits that we make in a measurement, plus one estimated digit. And lastly, you need to be able to understand that our precision is always limited by the measurement tool that we use. So if we take a look at a sample measurement tool, this is a ruler, we're going to walk through the 2 steps that you always need to follow in the laboratory when you are asked to take a precise measurement. The first step is to look at the tool that you are using and determine the interval value of the instrument. In other words, what's the value for each of the little lines on the tool or the instrument? In this case, if we take a look at our ruler, we can tell that each of these lines has a value of 1. So our interval value for this ruler is 1 centimeter. Now our second step is, once we've determined the interval, we're going to record our measurement just like we normally would, but we're going to record our measurement to one place past the interval value. So if our interval value is 1, our measurement needs to go out to the 10th place. And so a good measurement that we could make with this example is 22.2 centimeters. Notice that I have 2 known values, the 20 and the 2, and I have my last digit is an estimated digit. I've looked at the line on my ruler and I've estimated that that is approximately at 0.2. I have 2 known values, I have 1 estimated value. These are all significant figures, or what we refer to as significant figures in chemistry. So what we're going to do now is we're going to go through just several examples and follow the same 2 steps. It's always the same 2 steps. The first is determine the interval. In this case, this is a graduated cylinder. You can see the meniscus, the curvature of the liquid at the top. So if we take a look at each of the little lines on this graduated cylinder, we notice that the interval value is 1 milliliter. The second step, just like before, is we're going to record our measurement to one place past the interval value. So if our interval value is 1, our measurement needs to go to the 10th place. So looking at where my meniscus lies, an appropriate measurement for this particular reading would be, let's say, 38.4 milliliters. I'm estimating the 4. Another student might estimate that last digit to be 0.5. Either way, I have 2 known digits. I have 1 estimated digit. So in this particular example, I have 3 significant figures. These are all important in taking a precise measurement. Let's look at a different graduated cylinder. Notice now that when I'm going to determine the interval value, my interval value is different than my previous example. In this case, my interval value is 1/10 or 0.1 milliliters. So when I go to take my measurement, and always remember on a graduated cylinder to read from the bottom of the meniscus, when I go to record my measurement for this example, I need to record my value to the 100th place, which is one place past the 10th place. So an appropriate measurement might be 9.57 milliliters. The 9.5 are my known digits. The 7 that's in the 100th place is an estimated digit. Again, I have 3 significant figures in this example. Although we rarely use the triple beam balance because now we use electronic balances, it's an important tool to take a look at to make sure we understand this concept of significant figures and making precise measurements. So in a triple beam balance, remember we have 3 beams. We have a hundreds beam, a tens beam, and a ones beam. So when we determine the interval, we're always looking at the smallest value of interval. So we're going to focus the interval on the ones bar. So if I look at the ones bar and I notice the spacing between the numbers, I realize that the interval value is 0.1 grams, because a triple beam balance is designed to measure mass. So when I make my measurement, I need to go out to the hundredths place. So on a triple beam balance, I would add up the hundreds bar plus the tens bar plus the ones bar, and I'm going to estimate my last digit. So I'm going to record my measurement. Notice we're following the same 2 steps as before, and I might end up with something like 278.14 grams. The 278.1 are all of my known values. The 4 that's located in the hundredths place is an estimated value. In this case, notice if I'm trying to add up or determine how many significant figures I actually have 5. 1, 2, 3, 4, 5. I have 4 known values and 1 estimated value in the hundredths place. So this video, we went over how to take a precise measurement. We went over the 2 steps that we follow every time we are in the laboratory taking a measurement. We've also talked about the definition of significant figures, and we've gone through how to determine how many significant figures would be in a measurement. Make sure that as you've gone through this video, and feel free to pause and rewind, that you have written down the measurements that were in the video so that we can talk about those in class next time.